So at this point, I would like to bring Megan Carrier. She's the product marketing engineer for robotics here at National Instruments, and she's going to tell us a little bit about what we've been working on. And Megan, I see you brought a friend with you.
I did. This is my robot. I'll talk about her in just a minute.
Fantastic. Thank you for coming.
Thank you. So as Dave mentioned, robotics is a really great way to get students excited about engineering. In fact, National Instruments, with partners such as LEGO and Physical Education, provides a variety of robotics education platforms. So starting with the low-cost LEGO NXT platform, this includes a 32-bit microprocessor and some basic sensors and motors.
So there's a 32-bit microprocessor in that brain.
Yep.
Wow, that sounds pretty powerful.
It's great. It's actually being used in a variety of introduction to engineering classes at schools like Georgia Tech and Texas A&M.
Wow, wow. So what's this new platform I see here?
So this is our LabVIEW Robotics Starter Kit, and this is a more sophisticated platform. It actually has an onboard single-board reel to do real-time processing.
Fantastic.
And it's actually really easy for students to take this platform and program it to do things like obstacle avoidance and navigation.
Well, every time I hear easy, then I start to get worried. Can we really program this in a somewhat intuitive way?
Yep. Actually, Dave, with the new LabVIEW Robotics module that plugs into the LabVIEW environment, it's easy to program an autonomous robot.
All right, well, this I've got to see. So can we take a look at how you program something like this?
Sure. Well, as you all know, robotics are very complex mechatronic systems. So when we're teaching them to students, it's important to simplify them so that the students can understand what's going on under the hood. So we can divide the robotics process into 3 steps: sense, think, and act.
All right, let's see it.
Well, the first step is sense. So the robot needs to connect to sensors, acquire data, and visualize its environment.
So I see an icon here that says LiDAR. Now, is this a piece of the robotics module?
Yes, actually with the robotics module, we have a whole new suite of sensor drivers. So you can easily connect to everything from LiDAR, GPS, to sonar, you name it.
All right, so now we can sense with these types of functions. What happens next?
So next, we pass this data into some sort of decision-making algorithm, depending on the task of the robot. In this case, it's obstacle avoidance.
Okay, so this says VFH. Is this vector?
Vector field histogram.
A vector
This is a
field.
very common obstacle avoidance algorithm used in robotics.
I see, and I recognize the green wire. And to me, that means Boolean or true and false coming out of this. What's this telling me?
So basically, Dave, the robot is identifying everything in front of it as either an obstacle or a gap.
So true means there's an obstacle there.
Yeah.
And then we decide to go in reverse.
Correct?
I get it. I get that. All right, next one.
All right. And the last step, we're actually going to do our kinematics, maybe calculate wheel velocities, and then send commands to the motor so that the robot can act on its environment.
That's fantastic. But we're here to do engineering. Let's do some robotics engineering.
Oh, so when you combine those 3 steps, you have an autonomous robot.
So that's the program that would be running, or something like that right here?
It's very similar.
Very similar. Okay, let's do it.
All right. So I'm going to go ahead and turn her motors on.
This is supposed to avoid me now, correct?
Correct. So this robot is using an ultrasonic sensor in order to scan the environment and avoid obstacles.
I think it's more... Okay, it's avoiding me now. Good.
And it's running an obstacle avoidance algorithm on the single-board reel in real time.
It definitely avoided me, which would not be the first time that that's happened, but at least this is what it was programmed to do.
That's correct.
Okay, that's fantastic. Well, it's a great platform. I think it's a great place to start. How about other platforms?
Yeah, so this is a great out-of-the-box platform if you want your students to add some sensors to it, do some programming. But we know that a lot of students want to do everything from designing the robot, building it, to programming it, similar to the first robotics competition.
Fantastic. You know, I know about the robotics, first robotics competition, and they've got all these tens of thousands of screaming students at the Atlanta Dome, right? The Georgia Dome in Atlanta. This thing, it draws so many kids in. You're telling me that we have something along these lines.
Yeah. So as of today, we actually introduced a new platform, and that's called the NIRobotics Contact Reel Kit, or the NIRod. And this platform is based on the first robotics kit.
So this is the thing that they can use as a base to build up all those cool robots that we see at first.
That's right. You
That's
can now
right.
use that same platform in your robotics or mechatronics course or design class.
That's great. That's supported by National Instruments.
Yep.
Fantastic. Now I see this other one up there, custom robots, and the question I have, how custom can we make these robots?
Very custom. In fact, we have a robot here today that uses a compact reel and can be used to teach everything from forward and inverse kinematics to advanced control to path planning and navigation.
Wow, fantastic.
Yep, and it's all the way from Korea.
All the way, did the robot come all the way from Korea all by itself?
Well, it is autonomous, so quite possibly. But no, in fact, I'd like to welcome Gio Hwang from NI Korea and Dr. Khan from the Pohang Institute of Intelligent Robotics.
Fantastic. you're working on.
Yes.
And I'll move this robot.
Pohang Institute of Intelligent Robotics, along with National Instrument Korea, has been working on this project since late 2008 to develop a robot platform to teach students in robotics and related fields. Dr. Kang has been lecturing robotics education, and he has long seen a gap in robot education and wanted to actually develop a robot platform to teach students in this field. And he wanted to work with a reliable hardware and software company like National Instruments.
That's fantastic. So this is all about doing engineering. Can we actually do a robot engineering custom form right on stage?
Yes, since this year's theme is about doing engineering, without further ado, we'll be showing the big eye robot, but I need all of your support. This has a microphone built into it, and it'll need all of the applause to get this rolling. So please show some support.
All right. Oh, he's hiding. He's shy.
It's not a jet lag.
So when your robot has jet lag, do you have to program that in, or does that still happen?
Actually, the guy has two control modes. First, I show the passive control mode. We can, this means I can control the big eye with the V remote control. So we can make some gesture. The first, like this kind of action. And hello. And also the stones can make the action. And now I switch the control mode to the active navigation mode because the guy has several sonar sensors, so the robot can measure the environment and also it can make the map to the navigation in the world.
So as you can see from the top, there's a vision sensor, and then if you can switch to the projector, we'll show you what the big eye is seeing right now. The image is not clear because we're using the ARC camera and we're having some interference, but we're using NIWeek to do simple image acquisition and image processing, like such as pattern matching and OCR. From the arm and to the bottom, the wheel, so motion control, and we're using the Labiat PGA with the counter wheel to accomplish this. To stay this in balance, like an inverted pendulum, as you can see, it's using the real-time PID control, using the Labiat control design and simulation toolset.
Now in the big eye, so I see Compact Rio is basically the body of the robot.
That's the key of the robot. Couldn't have done it without the Compact Rio. As you can see, we're leveraging almost all entire Labiat platform. And the good news for all of the audience here, all of this toolset that we're using here are built into the academic site license, so you don't have to worry about obtaining all these different tools.
That's fantastic, and I know just to balance, maybe we take that for granted now, but that takes a lot of computing power to balance, plus you're doing the vision, you're doing the movements. This is a very complete little robot.
Yes, it is.
That's fantastic. One of the questions we always get, though, is if I want to use this for teaching, how do I do that? What materials are available, and what can I use to get that done?
Well, that's a great question, David. Actually, Dr. Gang and our local alliance partner, Unmet Solution, have been developing this full courseware that goes along with this robot. So if you want to see this in further details, we're going to be at the Robotics Pavilion, at the Big Eye booth, and it's officially released, so anybody can actually get this robot to teach the robot.
I guess you have to say that when great theory comes together with great controls and an artistic talent, you created a great robot here. But I want to say something though. You took the time to develop this, you made the curriculum materials, you developed that in Korean, but then you went the extra distance to put it into English so that many other people around the world can use it. Is that right?
That's right. It's for the robotics community.
That's very, very generous, and I think that deserves a round of applause. Thank you for that.